the books, it's all proven troubleshooting techniques that I have developed and others have developed through the decades, really. And so I'm really including all my latest troubleshooting techniques. So it's something I'd like to be able to pass on to the younger generations of engineers.
Hi everyone, it's Judy Warner. Welcome back to the OnTrack podcast. We have the one and only Ken Wyatt of Wyatt Consulting. He's here to talk about his new book, and I can't wait to share him with you and teach you more about EMC expertise. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Ken. So good to see you. Good to catch up again. I saw on LinkedIn your third book is out.
Yes, thanks, Judy, for having me.
Well, we promised our listeners that when you came out with a third book, we'd have you back. So I'm trying to make good on that, on those promises. But for those who didn't see our last couple of installments, why don't you talk a little bit about yourself, your background, and then just give us a little brief overview of Wyatt Technical Services and your recent book series.
Well, I started my career in aerospace world as a designer for 10 years, and then transitioned over to Hewlett-Packard and Agilent Technologies, and where I spent the bulk of my career, over 20 years. And I've been consulting now in EMC, which is my specialty. And doing that since 2008, the year of the financial crash. Bad time to start a business, I guess, but I have survived since then.
Well, EMC problems don't care if there's a financial crash, I'm sure. And from everything I can see that you're doing online, there's been no grass grown under your feet. So
I've
tell us a little
to stay
bit.
busy.
Yeah, you do. So Ken, talk about, just give us an overview of the 3-book series you've written, why you wrote it, and then we'll talk more about EMC in general after that.
Okay, so the main reason I decided to write the books is there are so many clients that I've had that have the same old problems, problems with cable shields, grounding, shielding, just basic design issues. And so many of these companies that I help are either startups or medium-sized companies that don't really have a full-time EMC expert on staff. And in fact,
Right.
the trend has been, even with the larger companies and the downsizing and so forth, that EMC engineering usually has a lower priority, and so it really forces the designers to wear many hats and not only be good at design, but good at the regulatory issues like EMC. And a lot of companies, a lot of my clients tend to save EMC compliance for the end of the product cycle, and that's always painful. Sometimes I can help them, sometimes I can't without major redesigns. So that's the reason I wrote the books. These 3 books are really oriented towards the product designer, which is different from most EMC books. A lot of the EMC books are really focused on EMC engineers rather than designers. And so I decided for my project last year. During the pandemic, I decided to write these 3 books. The first book, Volume 1, is all about how to collect the right instruments, probes, and accessories to do your own EMC troubleshooting right on the workbench. Volume 2 is all about troubleshooting emissions, so that would be including conducted and radiated emissions, which are radiated emissions is usually the number one issue people have. Mm-hmm. And then Volume 3, which just came out last month, is all about troubleshooting immunity issues like electrostatic discharge, radiated immunity, which are 2 big ones for people, and other immunities like electrically fast transient and so forth.
For those of us that are not initiated in your world, what is immunity?
Products to be able to sell or market worldwide are required to not affect their environment to some degree, and the environment should not affect your product. That's electromagnetic compatibility. So your product doesn't interfere with radio and TV and communication systems, for example. That would be emissions. And various energy sources in the environment, like electrostatic discharge is a good example, should not impact the operation of your product either. And powerful, broadcast services shouldn't affect your product as well. So that's really what EMC is all about, is making sure your product is
vaccinated,
a good citizen in the environment.
Yeah. Well, it cracks me up that you would write this book at this time when everybody's talking about vaccines, right? So when you're talking about it, it makes it immune, right? So that's what, my simple mind goes to. But it sort of is. It's creating, bidirectional immunity from interference and things like that. Okay, we're going to talk about your book a little bit more. Now, I will say you mentioned that because of this move away from having in-house EMC experts, people, design engineers, product engineers have been sort of left to fend for themselves. And the books that are out are at an expertise level that they assume you probably have some kind of base knowledge. So these books sound like they give you the fundamentals, but build on that a bit. Would you say that's a fair characterization?
Yes, I go over some fundamental EMC theory and product design tips, but there's a couple problems. The first problem is that engineers aren't educated in this area.
Yeah.
In colleges and universities, so they have to learn the hard way. And in so doing, the second issue that a lot of companies run into is that they'll take their product, which is almost ready to market, and take it to the compliance test lab where they'll have multiple failures probably, and so that's back and forth between trying to troubleshoot the issues and then taking it back for compliance testing and maybe failing again, and it's almost like an endless cycle. And so the books, the content is very practical. It's all proven troubleshooting techniques that I have developed and others have developed through the decades, really. Mm-hmm. I used a lot of these techniques when I was working for HP in the early 1990s. And that's where a lot of these techniques have been developed and refined through the years. And so I'm really uh, including all my latest troubleshooting techniques in these books, and so it's something I'd like to be able to pass on to the younger generations of engineers.
Well, that whole idea is near and dear to my heart. So I love that you're making this accessible. And for our listeners, I'm going to put the link to Ken's books down below, and I would highly recommend them. Ken, I think you said they're available in digital and print formats, correct?
Right now, just print. I'm
For the latest book, you mean?
I'm considering making Kindle versions, but they're all
Okay.
available on Amazon as relatively low cost, for an engineering book. Uh,
Yes.
so my hope is that a lot of designers will purchase these and be able to do their own troubleshooting, and then maybe call me or other EMC consultants in when they really run into a tough nut to crack. So many of the issues that cause failures are relatively easy to solve, and so I'd rather have my clients be able to learn enough to fix the easy things and then call me later.
Now, these things that they will be fixing, do you teach them preemptive things? In other words, avoid common design mistakes as well as after, or once it's done and they have a problem, kind of to know where to look instead of going on some ambiguous treasure hunt?
So one of the chapters deals with the basics of product design for compliance. Um,
Okay, good.
there's actually more information in the book that Patrick, Andre, and I co-authored called EMI Troubleshooting Cookbook for Product Designers, and that's been out since 2014, I believe, is when it was released. And that book is also available on Amazon, and it really goes into more product design details than these troubleshooting books do. But there is some basic information, and then the troubleshooting techniques. I do provide a lot of potential mitigations that they should try. So hopefully these books will aid in at least helping them resolve some of the easier things to resolve in their product.
Ken, what are some of the biggest issues specifically that product designers face when complying with immunity? Did we really cover that, or can we go deeper on that? I'm going to restate that
Yeah,
question.
we can go deeper.
I think we should go deeper there. Okay.
There's really a couple very common immunity issues that designers run into. One of those is radiated immunity, and I have developed. I'm sure it's not original, but what I do, radiated immunity. What the test is consists of is transmitting a moderately powerful RF signal at your product to see if it will cause disruption. And it's a very lengthy test. Requires a shielded room and you know relatively strong RF power amplifiers and antennas. And so they'll sweep the RF spectrum and see where your product might stop working properly.
Hmm.
Now I've developed and I've used this technique for a couple decades at least, where I'll create a localized RF field around usually an H field probe, one of the small loop probes, and I'll connect that to an RF source and sweep that around the circuit board to try and find sensitive nodes or cables that are acting as antennas and feeding in this RF energy and causing disruption. And a lot of times I can use that probe with a localized RF field, which is quite strong around the tip. Or I use a standard little walkie-talkie like you use
Mm-hmm.
or purchase at Walmart, and just transmit with that and see if it causes disruption. There's one client I helped that they were making some industrial machine, and most of the troubleshooting was done with just a little walkie-talkie, and the problems were the shielded cables. The shield was not terminated, so the cable wasn't shielded, basically.
Wow.
And so we did all the troubleshooting with a little walkie-talkie. And other clients I've helped with just sweeping the little H-field probe around their circuitry and cables and finding issues. There's one case where I was troubleshooting a medical product. It was a blood analyzer with some motors, and the motors are supposed to pump the blood out of the patient, analyze it, and put it back into the patient. And two of the motors were taking off at 10,000 RPM, and that's
That's a
probably
bad day.
that's not a good thing to be pumping your blood out that fast. So so I was able to use a piece of coax, make a little larger loop, and feed RF into that loop, and we discovered that there's a couple of encoders on the back of the motors in question that were affected by the RF. And this company had been working for weeks, going back and forth to the compliance test lab and trying to shield and bond and ground everything properly. And I was able to find and fix their problem within a couple of hours. So that's one thing. Electrostatic discharge is another very common issue that people have.
Yeah.
And it turns out that as you decrease the size of a product, for example, some wearables have very small circuit boards and very low voltages. You don't have very much design margin as far as what's a logic high and what's a logic low, and so a strong electrostatic discharge can disrupt your digital circuitry and cause microprocessors to sometimes reset or
Oh.
just cause glitches in the data. And so it involves shielding and examining the path that the ESD current is taking and so forth. So I explain some of those concepts in that new book.
So, in that regard, this specific topic, can you think of one or two? I try to give our listeners some takeaways. So, is there one or two maybe preemptive things that our design engineering customers can think about, or our listeners can think about around ESD specifically?
Sure. It all comes down to what your company does. It's all usually all about the circuit board and the stack up that is used. I know that a lot of companies pull in design techniques from years ago where we didn't have very fast clock rates and products were bigger and easier to shield and with especially wearables with unshielded plastic cases. They're a lot more affected by electrostatic discharge, and it turns out if you get the stack up wrong, it just leads to multiple EMC issues, including electrostatic discharge. So, and I've written articles for EDN.com on how to design low EMI PC boards. And really the trick is to ensure that all signal layers have an adjacent return plane, a solid return plane, and all power layers have an adjacent solid return plane. And if you use that concept when you're designing your stack up, you're going to avoid a lot of EMC issues.
Okay, you're going to need to share that article with me and dig that one out, Ken Wyatt.
I shall.
Thank you for sharing that. And on a broader level, what has the rise of IoT done to this thing that exists, this lack of knowledge and education around EMI, EMC, because so much wireless wearables, what has that done? Are you busier than ever, or what's your observation?
Well, a lot more companies are incorporating wireless into their products, especially cellular. And it turns out that, yes, I've been very busy with various wireless clients. And the biggest issue that I've seen is self-generated EMI coming from the boards and contaminating the receiver sensitivity of these various wireless modules.
Okay.
And cellular is particularly affected because the cellular providers require a certain sensitivity on the receivers before the device is allowed on their systems.
Mm-hmm.
It's called total ISO. Now I can't think of it. TIS. It's a sensitivity for the receiver. Sorry about that.
That's okay. That's
a mental
okay.
block. But yeah, if your cellular receiver isn't sensitive enough, the providers don't want it on their system because it forces their transmitters to go to a higher power level, which can lead to interference from cell site to cell site. So they require a certain sensitivity, and very very commonly it's digital bus noise, or in particular DC to DC converters switching that causes broadband EMI that couples into the receiver. And so the smaller the board is, the riskier this issue. And so I've been working with a lot of clients to mitigate those kind of things. And again, it's all about the PC board stack up and layout. It gets more and more critical as the product gets smaller and smaller.
So you touched lightly in the beginning on that design engineers don't learn this, say, at university. And since there's no formal education on it, they may get in the industry like so many do because of being forced to wear so many hats. And like I said, then they lose their nights and weekends trying to, figure out where this problem is. What can industry do? What can universities do? Like, how do we solve this educational gap, Ken?
Well, that's another hot button for me. When I was, I had announced that I was going to retire myself early from Agilent Technologies, and in fact, I announced it 2 years early to my boss, which is, I guess, unusual. But it allowed me to hire my replacement and train them. And I interviewed a dozen different new college grads with either bachelor's or master's degrees. I invited 3 in, and none of them cut it technically. I was really surprised.
Wow.
That they didn't really know basic electronics that well, nor did they have a practical grasp of how to design. I ended up having to hire a PhD to replace me
Wow.
from University of Missouri at Rolla.
Oh, and that's because Professor Todd Hubing
Yes,
probably has one of the few programs in the country that covers EMC.
that's you hit it on the head there.
Well, because Todd, of course, came on the show and told
Yeah,
us that idea. So as soon as you said roll, I'm like, I know why.
yeah. There's a number of top educators that have come out of Rolla. So yeah, I knew to contact them once I was had given up, hiring regular
That's,
college
that's
grads.
amazing.
But yeah, University of Missouri is one of the top colleges that they actually have an EMC lab with as many as 50 grad students or post grad students. There's maybe a half a dozen professors that work just in that lab.
That's amazing.
And there are other universities that have EMC programs. University of Oklahoma in Tulsa has a program. Grand Valley State College um, Michigan, Southern Michigan, has a program. And there's many others. University of Zaragoza, you might know
Hmm.
Arturo Mediano. He's a professor in Spain, and has an EMC program in their college. The problem with most colleges and universities is that um, they've got their curricula figured out, either 4 or 5 year curricula, and there's it's really hard for them to convince them to add anything.
Yeah.
And so there's that. There's some other reasons that they don't want to add something, but
Well,
it,
I mean, what others in the industry have taught me is because there's not research dollars attached.
right, and that's what's unique about University of Missouri, is because they partner with usually a major corporation like
Mm.
Sony or Panasonic
Mm-hmm.
or several others. Um, the companies will come in with a problem that they want the grad students to work on, and at the same time the students will create practical papers
Yes.
and help the company get through their EMC issues.
Mm-hmm.
So it helps industry and it helps the students,
Yep.
and that's what's successful. Clemson University is another example. In fact, that's their
Todd
automotive.
Hubing again.
Yeah, their automotive EMC lab was started by Todd Hubing, and so that's another area or another example where industry and the university partners, and that's really a major trick to helping students learn about some of these topics that aren't in the regular curriculum.
Yep. Well, you'll be happy to know there I sit on a corporate advisory board at an organization called Aceta, the ECE Department Head Association.
Mm.
And sometimes I sit on that, I'll sit on a panel about like lifelong learning or how industry and education can partner, right? And there's other great companies there like Keysight and Texas Instruments and others that are coming alongside ECE department heads and trying to fill that gap. And so I love being part of that conversation, right? To get some of that practical. And what we're noticing, and I don't know if you are, is the ones that have really stood up in this area are the people who are running the labs at university. They've sort of become the champions.
Sure.
Have you seen that at the universities you've worked with, Ken?
Absolutely. Yeah, I swing by University of Missouri periodically to see what's going on and to give presentations and talk to their students. And any kind of industry university collaboration is really good.
Really good.
Yeah, in my case, just on a personal level, one way to get around the curriculum issue is university extension courses. And that's what helped me. We had an engineer in Hewlett Packard that wanted to teach out of Dr. Clayton Paul's textbook. And so I took a course at the University of Colorado here in Colorado Springs.
Mm-hmm.
It was a semester long, and that I have to say that was a major influence in my own career as a trainer. I later took that information from Dr. Clayton's book and taught internal Hewlett Packard and Agilent courses, and all that training helped launch my own career. When I decided to consult. And
Well,
so,
that's a good tip and one that I might drag off to Aceta when I'm talking to these ECE department heads when they're like, "What can we do?"
yeah.
I'll
So
give them your tip, Ken.
that's a great way to get around the reluctance to add more to the existing curricula that they
That would be good for PCB design practices as well.
exactly.
Using an extension program, that's a new idea. So that's fascinating. See, that's why we have you on, because you have all these little tips and tricks that are very practical because they've been won in the school of hard knocks over many, many decades. And so, well, I think I put one too many in there, over many decades. I don't want to age us too much, Ken. Well, thank you so much. I've taken up a bit of your time, but thank you so much for hopping in today. I know you've got a conference coming up. Why don't you tell our listeners a little bit about that, and then we'll wrap up.
All right. So I was kindly invited to be the keynote speaker and the primary speaker for the day in Minneapolis. The Minnesota IEEE is hosting a regional EMC event, they call it, and hope to attract engineers from the whole Great Lakes area and that part of the country. And my keynote is on the lack of EMC training and what we can do as industry to collaborate with colleges and universities. So you got a little sneak preview.
Oh, that's awesome. Well, that worked out well. It's
And then
almost like we planned it, but I swear we didn't.
no,
We didn't do
well, it's
that.
just on my mind.
Yeah, I love that. So, okay, so I'll share that conference in the link below.
Right.
So I'll need to get that from you, Ken. And also for folks that are just like, oh, forget it. Ken just taught me that there's a bunch of stuff that I don't have time to know. I'll just call Ken Wyatt. What's your website so they can gather more information and resources or get in
It's
touch with you?
www.emc-seminars.com.
Okay,
And I'm
excellent.
always happy to answer general questions on EMC.
Okay, last thing that just occurred to me, Ken. IEEE has an amazing EMC society, right? Is that something that you'd recommend that our maybe listeners attend their
Yes,
conferences or get involved in?
yes, certainly. If it looks like your boss has put the EMC hat on your head as a designer, I would highly recommend joining the IEEE EMC Society. And there's chapters all around the world, actually. And in this case, the Minnesota section is hosting this special event, which I believe is annual, but it does attract a lot of interesting speakers each year.
Yep, and I know Dr. Eric Bogatin's involved. I know Dr. Todd Hubing, yourself, people I really respect, think very highly of that society and both contribute to it greatly, but then also, have learned a lot over the years. Okay, that was a good tip. Well, you've given our listeners way more than one takeaway today. So thank you so much for jumping in and sharing your time and resources. Congratulations on getting this trilogy completed. Hopefully
Yes,
you and your wife can go take a vacation and hit
we
the road
we,
here
we
soon.
plan to take a long road trip to celebrate. So thanks for
Well,
having me on.
yeah, well, okay. One last thing. I'm going to do it. I haven't done this in forever, Ken, but you make me want to do it. So, we used to do this thing on here called Designers After Hours, but we'll just call it EMC Experts After Hours today. So, what do you do in your spare time when you're out vacationing?
Ah, okay. Yeah, so my wife Sheila, her passion is lighthouses, and she wanted to photograph all the lighthouses in the country. There's some 850, and we've finished the East Coast and produced a book, co-authored Sheila and myself. We have enough content now for Florida and the Gulf Coast, which is going to be volume 2. The West Coast will be volume 3, and right now we're working on the Great Lakes. And so following this conference in Minneapolis, we'll be heading off to finish off some of the Great Lakes lighthouses, and there's over 200 that we still have to do.
Well, after I learned this little tip about Ken Wyatt last time, I love photography and I also love traveling and RVing and all that. And so he and Sheila gracefully sent me a copy. So I'm also going to put that in the show notes because Ken's not busy enough. He needs to publish books about lighthouses, but you'll see so much beauty. So I'm going to share that one below too,
Thank you,
just
Judy.
because that's a wonderful piece of what you
Yeah,
do. Ken, thank you again for all you contribute to the industry. You're absolute gold, and we're so grateful for you. And thank you so much for giving us some time this morning to share with our listeners.
well, thanks so much, Judy. It's always a fun and a pleasure to chat with you.
And you as well. To our audience, thank you so much for joining. I'm sure you can tell from this conversation with Ken, I'm going to load up the show notes for you. So please go hunt down all those treasures that Ken Wyatt left behind today. I trust that this is going to help you get your nights and weekends back. So thank you for joining us again this week. We appreciate the time you spend with us. If you like it, please give us a like and subscribe. It helps the podcast keep moving forward, and it gives us fresh ideas and people to bring on. So thanks for all you do out in the industry to just transform the world every day. We'll see you next time. Until then, remember, stay healthy, stay safe, and always remember to stay on track.